When you're investigating the probability of two independent events, you're looking at events where one does not affect the outcome of the other. Now, you'll remember from the previous lesson where we just talked about probability that if you flip a coin, the number of probable outcomes is 2. You could have a head or you could have a tail. So there are only 2 possible outcomes. So the probability is the number of favorable outcomes divided by the total possible outcomes. So if you want to say the probability of getting heads, there's only 1 possible outcome there, or favorable outcome, and there are 2 total possible outcomes. So that's how you determine probability when there's only one event. When there's 2 events, you look at each event separately, but you combine them. So we're going to take the example of a coin toss and a roll of a die. Now, when you when you toss a coin, again, there are still only 2 possible outcomes. And when you roll a die, there are still only 6 possible outcomes. But when we combine the two, when we say the possibility or the probability of tossing a head and rolling a 4, we have to look at the combinations. And the easiest way to do that is to draw a tree diagram. And we start with the first event. So the first event was a coin toss. Well, what are the possible outcomes of a coin toss? So we write the 2 possible outcomes here as an H and a T. There's only 2 possible outcomes. So that's from the first event. Now the second event where we roll a die, we have 6 possible outcomes. But that's 6 possible outcomes for each of these results. So if we roll a heads, we then roll again, and there are 6 possible outcomes if we roll a head. If we roll a tail or if we toss a tail, we also have 6 possible outcomes. So to find the total possible outcomes, we look at this bottom result, because our result could be head 1, head 2, head 3, head 4, or tails 1, tails 2, tails 3. So our total is at the bottom here. So there are 6 if we flip a heads on the first one, 6 if we flip a tails. So there are a total of 12 possible outcomes of flipping a coin and tossing a die. So if we're looking at one particular outcome like heads 1, you can see that there would just be one possibility there, right here, out of the 12. So the probability would be 1 out of 12 for any one of these results. If you're looking at the probability of flipping a tails and getting an even number, you have 1 here, 1 here, and 1 here. So that's 3 out of 12. And don't forget that these need to be stated in simplest form. So that in fact would be 1 out of 4. So when you're doing a tree diagram, make sure you start with the first event up here like this, and then branch off like a tree branch for the second event. At the bottom will be all your results, and these are all the sample space. So our sample space has 12 different results in it. It's possible to show the exact same thing in a table or chart. You just need to put one event in the columns. So in this column we're going to put the results of the first event, heads or tails. There's only 2 results there. And then in the row across the top we're going to put the results of the roll of the die. So we've got 6 there. And in the intersecting spaces we're going to put what the result was. So in this case it was heads and 1, heads and 2, heads and 3, heads 4, heads 5, heads 6. And then in here, same thing, tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So again, you can see that there are 12 different outcomes. So you look in this space in here, the 12 different results of the coin toss and the roll of the die. Each event only has a possibility of occurring once. So tails and 1 has a probability of 1 out of 12. So you're counting up the inside spaces here. So either way, a tree diagram or a chart will give you your sample space for 2 independent events. If you're looking at the probability of flipping a tails and getting an even number,